Good day, everyone. We're in the next group that is signed on topic 4, which is all about manufacturing beverages. So first, we're going to tackle about the importance of manufacturing beverages. Manufacturing beverages produces 1.9 billion drinks a day. This is important as drinks or beverages are essential to the daily life of human, as without them, people will succumb to dehydration. And also, aside from this, having to produce 1.9 billion drinks a day ensures that all people will have sufficient drinks that they could intake. The next one is it produces an estimate of 44.29 billion US dollars. This is important as it also helps the economy of the country. Aside from this, it employs millions worldwide. This helps people to have a secure job because of the demand of manpower in the manufacturing of beverages. Manufacturing of beverages also is a part of daily diet of people. These beverages not only include soft drinks and alcoholic drinks, it also includes nutritional beverages, tea-based and milk-based products. And lastly, it supports the country's economy. This is connected with the estimation value of 44.29 billion. So the next one is the materials preparation in beverage production. The first one is the fresh fruits. This is important as this is the primary material in terms of products such as fruit-based, orange juice, beverages that uses the material of the fresh fruits they needed. The next one is water. Water is the primary raw material for production. Water needs to be pure, as being impure water, it makes the product cloudy, sediment, or easily contaminated with microorganisms. So this is why water should be pure water. The third material or ingredients that is used for beverage production is carbon dioxide. This is the one of the critical ingredients for beverages, as this product accounts 94% of the world beverages market share. Carbon dioxide role is to add sparkle, and it also acts as a mild preservative. Carbon dioxide acts as a mild preservative as it protects the soft drinks fresh, and it's also prevents the growth of bacteria in the liquid while being stored. So the next one is sugar. Sugar is one of the main ingredients in soft drinks. This adds sweetness. It can be either dry or liquid form. It brings deliciousness to the soft drinks, and it also helps in balancing the flavors and acidity. The next material is flavorings. Flavorings, as this is essential in soft drinks, as it adds artificial flavoring, and it also creates a level of natural like aroma. Flavorings can be classified into two levels: industrial grade and food grade flavoring. The last material is preservatives. Preservatives prevents microbial growth, and it also prevents the spoilage of the beverage products. So the next slide, we're going to see the classifications of beverages. So it can be non-alcoholic. This is also known as temperance drink. These beverages is made without alcohol, or it can be reduced to almost zero. The next classification is mineral water. This is the popular beverage, as this is the essential drink that people need, which is water. The third classification is alcoholic. This can be either beer and wine. It contains ethanol and produced by fermentation of grains and other sources of sugar acts as a drug for this beverage. And lastly, it can be also distilled alcoholic or liquor. It is produced by distillation of grains, fruits, vegetables, or sugar that is already gone through the alcoholic fermentation. So the next slide, we're going to see the different classification of beverages. In here, we can see the alcoholic and non-alcoholic side. In terms of alcoholic, it can be either non-carbonated or carbonated. Non-carbonated includes fruit juices, fruit drinks, fruit nectars, coffees, and tea products. On the carbonated side, it can be sodas, Coca-Cola, and tonic water. In terms of the non-alcoholic side, it can be either fruits or sap or grains. In terms of fruit or sap, it can be either non-distilled or distilled. Non-distilled products are beverages such as wines, and on the distilled products, it can be brandy. In terms of the grain, it can be also either non-distilled or distilled. Non-distilled grain products are beers, while distilled grain products are whiskeys.
Now that we are all aware of classifying beverages, let's talk about its production process steps. So first, clarification and pre-filtration. The cleanliness of the water has a significant impact on the quality of the beverages bottles. Dirt, bacteria, etc. can reduce the taste of the product and cause the product to spoil quickly. Impurities in the water are removed through coagulation, filtration, and chlorination. A viscous precipitate or precipitate, ferrosulfate or aluminum sulfate, is mixed into the water. The flux absorbs the suspended particles, turning them more prominent and easier to catch in the filters. It is also necessary to adjust the alkalinity to achieve the desired pH level. A non-fiber releasing membrane, like pre-filter, could be used as a final filter. However, the fiber matrix of these filters may occasionally unload retained contaminants into the filtrate if subjected to extreme pressure, fluctuations, flow surge, or fluid hammer. These phenomena are not uncommon in the high-flow, high-volume piping systems beverage manufacturers use, and are usually caused by pump-on-off cycling, quick closing valves, and other process flow control devices. In certain cases, it may be more practical and cost-effective to use a clarifying filter, followed by more retentive refilters. This allows each filter drain to be used to its maximum capacity, removing as much contamination as possible. So the second step is final filtration. The water is then poured through a sand filter to remove any remaining impurities. Bacteria and organic compounds can damage the color or taste of water. So water disinfection is essential. Water is pumped into a tank containing the same small amount of chlorine until the reaction is complete. The chlorinated water is stored in the tank for about 2 hours. Next, the activated carbon filter will have the same task as the sand filter to remove chlorine in the water and remove residual organic matter. In addition, businesses can apply the membranes to the beverage production process, helping to ensure the complete removal of particles and microorganisms. The final membrane filter effectively removes 99 to 100% of unwanted microbial content and is ideal as a microbial barrier in a multi-barrier process. The third step is process monitoring. It's essential to ensure that your product is safe from microbes and other contaminants every step of your process. Inline sampling. Rather than just testing your final product, performing in-process testing or inline sampling allows you to build quality into your beverage by monitoring microbiological conditions throughout your process in just a few simple steps. Water monitoring. Since water is the main component of your product, the quality of your water is the utmost importance throughout your process. With Merck proven process monitoring products, you can easily monitor your water for the detection of microbial contamination. Next is product testing. Product testing is essential to consistently produce a safe, high-quality beverage. With Merck's advanced filtration devices, you can easily detect and verify potential product contaminants before they become problems. Rapid detection. Rapid detection methods allows you to identify microbial contamination earlier in the process. This significantly improves product quality management and the ability to release your beverage to market sooner. Air monitoring. Because your production environment is a potential source of contamination, it is essential to have the appropriate testing systems and procedures in place to ensure the safety of your beverage process and the safety and quality of your products. Surface monitoring. Surface monitoring allows you to add another level of reliability and safety to your beverage production when you monitor microorganisms on your equipment and other surfaces. Media and incubation. Media in convenient single-test 2 ml plastic ampoules, eliminating the manipulation of glass ampoules and avoiding the waste and spoilage associated with bulk package media. Lastly is ingredients mixing. The flavoring components, color, and flavor modifiers are dissolved into the exact solution to create a specific flavor for the beverage product. Each ingredient is transferred to the tank in batches and carefully mixed. The syrup will be removed from the cooking pot and passed through a filter to remove impurities during the beverage production process. In addition, the physical impurities that may appear in the sugar and water raw materials can also be removed. Syrup sterilization can be carried out under the influence of ultraviolet radiation or rapid pasteurization. In particular, fruit syrup pasteurization is a must.
Good day everyone, I am Emuel Jay, Mabao, the next presenter to continue the discussion. So, tank venting. The goal of tank vent filter is to maintain near ambient pressure in the tank while ensuring sterility in the tank, consequently protecting your beverage. Hydrophobic sterilizing grade filters are commonly used as air vents on processing tanks to remove microorganisms. High-quality vent filters ensure the protection of your beverage production while meeting stringent regulatory requirements. Sizing your tank vent filter. Using the right size vent filter is critical to your process. Improper tank vent sizing can result in low pump out rates, loss of sterility due to rupture disc or filter failure, or worst case, tank implosion. Fortunately, proper sizing is not difficult as long as the flow requirements and driving force are understood. To ensure proper sizing, contact a Merck specialist or technical services. Air used to replace a volume of liquid. Sizing the tank vent filter for pump out or fill rate is relatively a simple process. The airflow rate will be equal to the pump out or fill rate. Once your flow rate and pressure has been determined, use a flow or AP curve to determine sizing. Use air to compensate for the volume change due to steam condensation. At the end of a tank steam in-place procedure, steam in the tank will cool and undergo a phase change to liquid water. There are over 1,000 difference in volume between an amount of water in gas phase versus in liquid phase. During cooling, sterilized ambient air must be allowed into the tank to prevent a vacuum. When sizing the vent filter for steam collapse, you must know the vacuum rating of the tank and its volume. The vacuum rating of the tank and its volume can be calculated based on the tank dimensions including height, diameter, and wall thickness. Gas filtration. Fermentation or higher pressure gas filtration is sized using the ideal gas law and flow rate versus pressure drop curves for hydrophobic cartridges. Gas inlet pressure, temperature, flow rate, and pressure drop information are all required to size a filtration system economically. Typical gas systems are sized at 85 Newton meter cube per hour per 10-inch cartridge and an initial differential pressure of 0.07 to 0.15 bar. In carbonating beverages, air is one of the potential sources of pollution in your manufacturing environment. Contaminated air used in the process threatens product quality and reduces its shelf life. Carbon dioxide or any other gas must be free from particles and microorganisms. So in carbon dioxide injection, carbonization is the step of adding carbon dioxide into the beverages. The carbonation step is present in the processing of sparkling water and sparkling soft drinks. The carbon dioxide you inject into your beverage must be free of particles and microorganisms. So in carbon dioxide adjustment, this is a specific step in the processing of fermented products such as beer. The fermentation and propagation stages of yeast have produced a certain amount of carbon dioxide. The added carbon dioxide must then be adjusted appropriately to ensure a quality of product. So in bottle blower, this process is carried out in any beverage production process that uses PET bottles. Sterile air or nitrogen filter pasteurizes air quality, turning preforms into final PET bottles. So in the last step, the bottle filter. The air filtration method can be applied in the process of carbonated drinks. It is necessary to pressure the filler bowl before the filling process. The gas used in the filtering bottle process must also be microbiologically stable. So, housings. Food and beverage filter housings are available in 316L grade stainless steel or polypropylene. All food grade filter housings are constructed from materials which meet the regulations for food contact materials. Sanitary filter housings are supplied mechanically polished with a free-flowing design, suitable for applications in beer, cider, whiskey, water, alcoholic and alcoholic non-beverages, and food products. So, Sartorius filter housings. These are designed for sanitary beverage filtration applications. As for Sartorius lenticular filter housings, these were developed for liquid filtration applications. So, the materials ideal for housings is stainless steel. That is because the advantages of stainless steel is well known for its antibacterial properties, resistance to corrosion, and non-reactivity with acidic foods and beverages. Stainless steel is the ideal housing material for use in the beverage industry. Stainless steel provides easy sanitation, a long-lasting installation, cost-effectiveness, and compliance with strict regulatory requirements. So the characteristics for stainless steel are, it will not rust because no extractable will spoil or affect the flavor of your beverage. It ensures the highest quality, durability, and safety of your product. It is self-healing. Its alloying elements form a thin, transparent passive layer, so it's unnecessary to coat or protect your housing against corrosion. If a scratch or any damage occurs, The layer instantaneously reforms under the influence of water and oxygen.
Good day, everyone. I'm Angel Manuel, and I will discuss the seventh and the eighth process steps of manufacturing beverage. Let's start with the seventh process, which is the integrity testing. In beverage applications, it is highly recommended that it is best to perform filter integrity testing during its final membrane filtration step, as well as the before and the after use of the filters. The before process, the filters have been used, and the integrity testing monitors its filter's integrity prior to batch processing. This will prevent the use of a non-integral filter. And when performing an after process, a batch has been processed already, and the integrity testing will detect if the integrity of the filter has been compromised during the process. And if a failed filter has been detected, the operator will be notified immediately after the batch processing. This will eliminate the delay and as well as allowing a rapid reprocessing of the products. So there are two types of integrity tests, which is found in the next slide. So there are two types of integrity testing, the destructive and the non-destructive. Mostly in beverage applications, the routine test or the routine integrity test is on the non-destructive part. And on the non-destructive part test, there are three types, which includes the bubble point test, diffusion test, and the last is the water flow integrity test for the hydrophobic filters or the hydrocore test. The pressure hold along with the forward flow and the pressure decay test are the variations of the diffusion test. And due to the size of the filtration area and the type of beverage application, the usual integrity tests are performed in the diffusion test or along in the pressure hold test. We cannot perform the bubble point test in the beverage application, since the high membrane surface area generates significant diffusion, making it very difficult to detect the bubble point of the beverage. We are now down onto the 8th process steps of the manufacturing of beverage, which is the diffusion test. So as the gas molecules migrate through the water-filled pores of a whittled membrane, following a fixed law of diffusion, it has a differential gas pressure below its bubble point, and the gas diffusion flow rate of a filter is directly proportional to the differential pressure and its total surface area of the filter. And to determine the integrity of its filter, its gas pressure is measured that reaches or approximately at 80% of the minimum bubble point. And there is a certain criteria to define the diffusion, and it is usually given by the manufacturer through a certificate of quality along with its filters. So the diffusion formula is the dt is equal to d sub s times the n sub c. dt is the total diffusion of the housing, and DS is the diffusion specification of one filter cartridge listed in the certificate. So the DS is already given or provided by the certificate of quality by the manufacturer, and the NC stands for the number of filter cartridge contained in the housing. So our filters and the housings are only crucial if the diffusion measured is lower than the DT or equal to the DT value. So the diffusion test has the following process, which we'll be tackling in the next slide. So my last part of the discussion is the process of the diffusion test. First is for the hydrophilic and the hydrophobic membranes. In hydrophilic membranes, we wet the filter with water, and for the hydrophobic membranes is we wet the filter with an alcohol water mixture. Next is to slowly increase the pressure on the upstream side of the filter to the recommended test given by the manufacturer, and allow the system to equilibrate, which equilibrate is to attain equilibrium of the system, and then measure the gas flow at the outlet for 1 minute or using an inverted graduated cylinder, or even a flowmeter can be used to measure. And the last is if you get a diffusion flow reading higher than the specification, this only indicates that the following are having a wrong pore size, the temperature is greater than or lesser than the ambient, and it is non-integral membrane, or it's seal, and lastly, it has an inadequate stabilization time of the process.
Good day. I am John Cesar Montejo, and I'm going to discuss about pressure hold testing. So, pressure hold testing is the method used by most automated integrity test systems. So, it is also known as pressure decay or pressure drop test, in which it is just a variation of the diffusion test. So, in pressure hold testing, a highly accurate gauge is used to monitor upstream pressure changes due to gas diffusion through the filter. So, as we can see, before sa tank na siya gauge na ginagamit. So, the purpose of a pressure test is to ensure the safety, reliability, and the leak tightness of the pressure system. So, there are two types of pressure hold testing, which is hydraulic and hydrostatic. But hydrostatic is the most preferred method of pressure testing because it generates less stored energy, leaving risk to workers. So that would be how to define the pressure hold value. The pressure hold value is dependent on the diffusion flow and upstream volume. We can calculate it using the formula pressure drop equals to diffusion rate times time times atmospheric pressure over the upstream volume of the apparatus. So, the pressure hold testing is performed using much the same procedure as the diffusion test, except for step 4. So, sa step 4 kay ang pressure hold testing uses a highly accurate gauge to monitor upstream pressure changes due to gas diffusion through the filter. So, maura na ang nakadiferensya sa diffusion test o sa pressure hold testing. Next slide is breakdown of beverages manufacturing. So, first is packaging solutions. The purpose of packaging is to identify the product from one company to another. So, for example, we have this product na walay label or wala na specify kung asagi ka na company. So, what if ang consumer ato na product is satisfy sila or taas silang rating para ato na product? So, useless ang nabuhat sa kumpanya kung ang ilahang product is dili ma-identify nga sa ilaha gikan. So, mao na ang purpose sa packaging solutions. Next is raw material sourcing. So, raw material sourcing, dili lang na ang mga raw material na is dili lang kay katulang mga fruits, mga juices kung asagikan ang flavor. So, ang raw material also includes katong mga container, mga ingredients, ng sugar, and etc. So, next is beverage manufacturer. So, every manufacturer nakafocus. So, lahi-lahi ilang focus. For example, one company is nakafocus sila sa patsadahay o design sa ilahang bottle. One company is nakafocus sa tsada nga design sa can. One company is nakafocus sila sa flavor. So, every manufacturer kay lahi-lahi jud ilang focus sa or pagdiskarte sa pagbaligya sa ilang product. So, lastly is manage production and ongoing support. Next slide is manufacturing process. So, in every manufacturer, lahi-lahi sila og process depending kung unsa ang ilang output or unsa na product ang ilang ginabuhat. So, kani for example, clarifying, sugar dissolving, blending, carbonating, filling, and packaging. So, ang output ani or ang product na ginabuhat is mostly soda or soft drinks. And kanisang sa pikas wherein we have a raw material na grapes. So, grapes are being transported to the manufacturer, gi-crush, gi-fermentate. So, fermentate, gi-convert ang carbohydrates, sugar o gatong starch into acid or alcohol. And pressing, filtration. So, gina-filter ang wine para mas mapolish siya ayo. So, next is aging. So, aging, mostly wine magini siya. And bottling. And lastly is degustation wherein gi-consume na siya sa mga consumers. So,
Good day everyone, I am Shanna Rica Sabello and I'm going to continue to report regarding beverage development. So we have 4 different steps on developing a beverage. So first is the concept development. This phase allows the developer to perfect their vision, discuss ideas, and identify the needs and requirements. They will plan through price options and customize the perfect package to bring the concept to offer. So next is the beverage formulation. So the next step is the formulation creation and flavor sampling process. This is one of the most crucial steps in the creation of the concept as they will define and essentially create the beverage. So whether you are creating a carbonated, non-carbonated, functionally drink, or even a feast of its kind new creation, it is well perfectly planned. So the third step is the beverage packaging. So at the same time that the beverage is being formulated, the production team evaluates the use of aluminum cans, plastic bottles, glass bottles, or any of the other types of beverage packaging available. So the last step is the packaging level or label design. So in this step, it is the final step where packaging is involved or the design is involved for it has to be pleasing to the eye of the consumer, and also the beverage has its accordance to its design. So in this next slide, it is the equipments being used in developing or manufacturing a beverage. So first equipment is we have the heat exchanger. So in the food and beverage industry, heat exchangers reduce or eliminate microbial to make products safe for consumption and to prevent spoilage. Heat exchanger also heat or cool products during a variety of processing stages, including filling, drying, and concentration. Pharmaceutical food and beverage operations realized the value of heat exchangers in its several ways. So some of this is that the exchanger transfer heat without contaminating the heated fluids. Energy savings, regenerative heat transfer conserves energy by reusing heated fluids to heat fluids in repeatable cycle. And also, heat exchangers heat the cleaning fluids that remove residues from the system components. So next equipment is we have the dissolver. In the industry of beverage, production of sweet drinks requires the addition of sugar syrup. Purchasing the syrup can be very expensive, concerning the volume of the liquid material and thus transportation costs. So to reduce this cost, dissolving granulated sugar can be an advantageous alternative. So it can be done effectively using either a batch system suitable for small-scale manufacturer or continuous system ideas for industrial scale. So what are the benefits of the dissolver? So first is constant production and no interruption, low energy consumption, compact dimension and less footprint, and modular design for hot and cold dissolution.
Good day everyone, I am Edjoy May Ubanan from BSME 4B. So plate heat exchanger were first produced in the 1920s and have since been widely used in a great number of sectors. A plate exchanger consists of a series parallel plates that are placed one above the other so as to allow the formation of a series of channels for fluid to flow between them. The space between two adjacent plates form the channel in which the fluid flows. Inlet and outlet holes at the corner of the plates allow hot and cold fluids through alternating channels in the exchanger so that the plate is always in contact on one side with the hot fluid and the other with the cold. Generally, these plates are corrugated in order to increase the turbulence, the thermal exchange surface, and to provide mechanical rigidity to the exchanger. Plate and frame heat exchanger are highly efficient and typically have a small footprint allowing a more compact system design. Additionally, they have a relatively low steam temperature requirement, making them a desirable choice for CIP system because plate and frame heat exchanger are designed to increase or decrease in capacity depending on application. They are among the most versatile heat exchanger available. And lastly, the variation in the height and width that accommodate installation and system integration, plate and the frame heat exchanger can scale in depth as system capacities change. Plate heat exchanger have the general purpose of heating, cooling process fluid, for example, water, oil, glycerol, and etc. In the two-phase field, they are used as evaporator or condenser using refrigerant fluids in a vapor compression refrigeration cycle. Working heat exchangers commonly used for evaporators and condenser. So how heat exchangers work? Microplate heat exchanger are plate heat exchangers which can be used for the evaporator and the condenser. For example, within chillers and heat pump. The picture or the illustration you see is the plate heat exchanger, evaporator, and condenser. When used for an evaporator, the vapor liquid mixture enters the bottom of the heat exchanger where the thermal energy is transferred into the refrigerant, which causes it to boil and evaporate. Then this leaves through the top of the heat exchanger with some degree of superheat, while when used as a condenser, the hot refrigerant gas enters the top of the heat exchanger, where it begins to transfer its thermal energy out of the refrigerant and into the secondary fluid, which cools the refrigerant down and causes it to condense into a partly subcooled liquid state. Traditionally, shell and tube heat exchangers were used, and they are for certain application. But then along came the invention of the plate heat exchanger, which is much more compact and efficient heat exchanger. This can come in either gasket or base plate variation. Sugar dissolving. Sugar is a core ingredient in many of the world's favorite food and drinks. It can be added and dissolved manually in batches or automatically in a continuous sugar dissolving system. This process requires a significant amount of energy. The reason is, as you add sugar to water, its temperature level drops. To maintain the optimal temperature for the exact amount of sugar you need to dissolve, the equipment continuously doses the sugar in a highly controlled manner. This prevents overdosing and dilution and minimizes energy consumption. Is sugar dissolving a continuous or a batch? The sugar dissolution process is crucial in many processes, from beverage to juices, from sparkling wine up to beer re-fermentation in bottles. So what are the possible systems? We can definitely distinguish between continuous and batch systems. In continuous dissolving system, sugar is added in a continuous way in a tank through a cochlea controlled by an inventor. At the same time, water is controlled by a modulating valve and magnetic flow meter. A high efficiency mixing pump permits the continuous dissolution. Syrup is extracted by a Brix meter that controls the concentration. So in the case of batch dissolving system, water is first loaded into the tank. Then it is heated to the dissolving temperature and then sugar is added. Once the whole sugar is at the right temperature, the batch is unloaded. So there are three main reasons that make continuous sugar system more advantageous. Number 1 is less electrical energy consumption. Number 2, less quantity of steam consumption. And number 3, less time for preparation of the need syrup. These advantages are particularly important in the case of production of big quantities of sugar syrups. And here are the references used in this presentation. That's all for our report. Thank you and God bless everyone.